Okay, so welcome back. I am working on the radians now, and what I want to show you on this one is that just as we did this in degrees, it works the same way with radians. So when you're working with this one with radians, you've got sine, so you're going to do sine 5 pi over 4 cosine 3 pi over 4. And it's a plus, so it's cosine sine. And again, 5 pi over 4 and 3 pi over 4. Now, when you do this one, I told the kids today, I made this problem up and I was checking myself and I go, oh, that's not what I want. And then I go, oh, look at how this works out. It's beautiful. And I want to show you this. So if I'm at 5 pi over 4, that is in the third quadrant. Negative I started to say pi over 2, square root of 2 over 2. And this one is also negative square root of 2 over 2. All right. The next one that you look at, cosine of 3 pi over 4, is in the second quadrant. So this one is negative square root 2 over 2. And this one's positive square root 2 over 2. Now, be careful because we have to multiply these. All right, and so when I multiply them, the square root of 2 times the square root of 2 is 2. So this is going to be positive 2 over 4. And this one is going to be negative 2 over 4. And if you look at that, it's 0. And you're like, surely I messed up. But wait, this problem has a unique feature to it. These could have been added ahead of time because the denominators are already 4. So we would have sine of 8 pi over 4, and it thrilled me today in 7th period. Somebody got ahead of me and went, oh, that's 2 pi. And I'm like, you are so right. And it took everybody a minute, but everybody got that today. I didn't have to point it out. You got it. So this is the same as sine of 2 pi. And if you look at sine of 2 pi, that answer, the final answer is 0. Okay, so this 0, same thing. Now, why in the world would I show you to do it this long way when you could have taken this shortcut? Well, all I'm saying is sometimes you can work it out and it's a little easier if you have a problem like this, that you're allowed to add them together. That only happens when those denominators match, okay? All right, trust me on it. I've got to erase this part. Sorry, but I've got to have room to set this up. You know what? Control Z. Let's see if it'll put it back. I don't know. Yes, it did. Yay me. All right, so number 9, a little bit different, and I'm not going to work this out all the way, but I am going to set it up. So the fact that it's cosine means I've got cosine, cosine, sine, sine. 7 pi over 4, cosine 4 pi over 3, and it's going to be plus sine 7 pi over 4 cosine 4 pi over 3. And what I did in class today, and I'm just taking it to this far, is that when I'm working on cosine of 7 pi over 4, I go ahead and get the values of cosine and sine. So 7 pi over 4 is in the fourth quadrant, and so this one is square root of 2 over 2 plus negative square root of 2 over 2. That's these two. And then I'm going to go back and I'm going to find the 4 pi over 3, which puts me in the third quadrant, and it's over 3. So the over 3 is the same thing as my 60 degrees. So this puts me at negative 1/2. This one puts me, I made a mistake here. It should be cosine, cosine, sine, sine. So fix this. Should say sine, sine. You were like, wait a minute, what you doing wrong? Okay, sine of 4 pi over 3. I caught it because I was doing the same thing. I'm kind of glad I was. The sine is going to be square root of 3 over 2. square root of 3 over 2. Now, several of the kids picked up on this today and they said, I know I can do this and not have to break it down by pieces. So square root of 2 times negative 1 is negative root 2. The negative root 2 times root 3 is going to be negative root 6. And I'm done. Final answer, it cannot be reduced. Again, any of these answers you want to see the final on, please look at the key that's already online. All right, rolling down to number 10. This is the last type that we're going to learn how to do. And I took it a smidge too far, and I knew that was going to happen. Okay, that's where I want it. Okay, interesting. I don't want that to happen. Okay, got my colors back. Okay, so when I'm doing this one, I've got to work with method 1 is finding the multiples of 12. So I'm going to take 12, and I'm looking for fractions involving 12. 1 over 12 is not on the unit circle, but if I put 2 over 12 and reduce it, I get 1/6. All of these numbers are this list of numbers, pi over 12. Okay, some huge list of numbers, pi over 12. So 2 over 12 becomes 1 pi over 12, 1 pi over 6, which is pi over 6, and that's on the unit circle. 3 will go into 12, and that would reduce to 1/4, or pi over 4, and that's on the unit circle. 4 reduces to 1/3, or pi over 3, on the unit circle. 5 pi over 12 is not on the unit circle, so I'm not going to put 5. 6 over 12 is pi over 2. 7 over 12 is not on the unit circle. 8 over 12, you can divide out by 4. It becomes 2 over 3. So 2 pi over 3 is on the unit circle. 9 will reduce as well as 10. 11 will not on the unit circle. 12 will, 13 will not, 14 will, 15 will, and oh my gosh, we could do this all night long. Don't need to. Those are all the possibilities. Well, all of them that we could possibly need. Then you're going to look at this number. Now, 12 was the reason I chose 12 to be in the denominator, all right, and all the things that will go into 12. So when I have 5 pi over 12, I'm looking for something that will add up to give me 5. And I had kids do this right away. You can add them or you can subtract them. So if you take 2 pi over 12 plus 3 pi over 12, guess what? You get 5 pi over 12. So that would become what we had here. And then to work it out, and you could have done other things. Somebody said 9 minus 4, and they were correct. That would give you 5 pi over 12. So just saying, there's more than one answer, one way to do it. So this becomes 6. This becomes 4. So technically what I'm looking for is cosine of pi over 6 plus pi over 4. Now, any order that you do this in, because you are adding, is fine. All right, so then you've got it set up, and you're going to do pi over 6 cosine pi over 4, and it's going to be minus sine pi over 6 and sine pi over 4. And again, look up the answer and see what I've got on its learning. Now, method 2. You can change to degrees, but remember, there's no calculator on the test, so you have to know how to do this. 5 pi over 12, and this is the hardest ones, in my opinion, on the test. This is what the kids have the most trouble with. So you have to multiply by 180 over pi to change it into degrees. All right, so when I do this, the pi's cancel. I'm left with 12 into 180. I know that I can divide top and bottom by 6. So dividing by 6, I would get 30 and 2. oh, wait a minute, but if I got 30 and 2, 2 goes into 30 15 times, and that becomes a 1. Now I am only left with 5 times 15, so that gives me a total of 75 degrees. So now I can do cosine of 75 degrees is equal to what? Now, this is where you have your choice. 75 can become 45 plus 30. It can become 60. Nope, 60 won't work. 90 minus 30 won't work. 120 minus 45. Okay, those kind of things is what you're looking for. 135 minus 60. Any of that will be sufficient. And then you work it out and do the problem. So again, I'm leaving these for you to do. I'm not going to continue. This is bare minimum. And these problems, people wanted to see another tangent. I don't want to keep this going too long. The only thing I want to point out, because you have an example of each one of these and you can go back and re-listen to it. I want to point out 17, 18, 19, and 20. This is one that somebody asked about in fourth period. I wish somebody had asked in second period. But solve each, then determine the original function that you would have evaluated. I didn't know another way. I made up these problems, okay? So I could not think of another way to write this. So when you go to work this problem, solve, okay? Sine 135 cosine 60 plus cosine 135 sine 60. And then you go down here and you finish it out. Do your work, blah, 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 get your answer. This part right here that I have underlined, all I'm asking you to do is tell me what would this have been before you did the evaluation on it. Okay, this is the evaluation, filling in the equation. But I just want you to go ahead and add these. You're finding the sine of 195. That's all I'm looking for here. I want you to add these together. So when you come down here to this part, you're going to go down and you're going to set it up and work it out. But then you need to add these two. And so the part that I'm looking for right here, I've got to get a common denominator. My common denominator is going to be 12. 6 times 2 is 12. 3 times 4 is 12. So that means I have to multiply this by 2 and this by 3. Because technically I'm multiplying that side 3 over 3, this side 2 over 2. And that gives me 10 pi plus 9 pi, which gives me 19 pi over 12. Now, this sine of 19 pi over 12, it's not your final answer, and you don't need to know it to work out the answer. Because what I've done is I've set this up, and you're going to take it down and do your sine of 5 pi over 6 times cosine 3 pi over 4 plus ... all this other stuff that you need to do. Okay, so there's your hint. I wanted to pass that on because good questions were asked today. And I hope this catches you up. I hope this is helpful if you missed something in class. And those of you who are out completely, please use this. Use the key that I have posted. And this is as far as we got on our first 2 days. And I hope you see the reason for all of the review that we did in adding, subtracting, multiplying, dividing with those fractions. Have a good one.